This video is to answer a few homework questions out of 6.2 and 6.3 in WebAssign, just to give us a little bit of an overview. So let me start by opening the homework from 6.2, 6.3. So as we look at, let's look at the first question, which you may notice it goes ahead and puts the answer on there when I open it from mine. But let me highlight these two and let's see about answering them. So the first one, they give us this particular area, and they want us to find the corresponding z value. So we want to find what z has an area of 0.7673 to the left. Now, when you look up in the table, we need to make sure we're using the correct table. If you click on Appendix B at the bottom of the homework, for some reason it takes us to the wrong table. But if you go to the back of the book manually, or if you have a hard copy of the book, you can do that as well. But if you go into the ebook and then slide down, this is going to slide down. Sliding down earlier, just going slow. Oh. We may also be able to, okay. Thought if I clicked up there, it would get us there as well. All right, here we go. So if we go to reference pages, and then we could go to Appendix B tables. Well, let's see if we go to tables here, what it does. All right, here we go. So page T2 or T3, these have cumulative probabilities. Now the thing that's different between that and the one that when you click Appendix B under the homework problems, Appendix B under the homework problems gives you the area between any particular z value and the mean. So it just gives you that area. And for some problems that's okay, but it's easier when they give us the area that is to the left of a particular z value. So if we use our table and we want to find out which z value has this area to the left, we pull that table up and we look for an area of 0.76273. So as we scale through here, here's 0.7673. So we have z values on the outside, and these are areas on the inside. So if we're given z, we go to the outside and look to the in. If we're given area, we go to the inside and look out. So this 0.763 inside the table, this is an area that corresponds with a z value of 0.73. 0.73. So that's z, 0.73. Remember what z stands for. That stands for the number of standard deviations from the mean. So when we're 0.73 standard deviations to the right of the mean, this is how much area is in our left tail. That means how much area is to the left of that particular z value. Now if we go to the next one, we're looking for this z value that has an area of 0.7190 to the right of. Now, one problem is our table gives us z values and the area to the left of that particular z value. It doesn't give us area to the right. But remember, underneath our bell curve, there's a total area of 1. That means 100% of our data is underneath this curve. So if we're told one side, the other side is just a complement. And remember, to get a complement, we subtract that from 1. So this area is the whole thing. Take that part away, and that gives us what's left over here, 0.2810. So that's the area to the left of that z-value. Double check. 1 minus 0.7190, 0.281. So we need to find out which z-value, what z has that area to the left. So if we go to our table, we know, let's see, if we look at our table, all of these values are larger than what we're looking for. So if we go on this side, let's see, we were looking for 0.281. So 0.281 is right here, 0.281. So if we look to the left, this gives us our first decimal, so negative 0.5. And if we go up, this is in the 8 column, or the 08 column, so negative 0.58. Negative 0.58. That's the z-value that has this much area to the left, which is like saying that much area to the right. So that z-value has that much on one side, that much on the other. So that's what they were looking for in that first problem. Now, in number 2, they ask us about some percentiles. So let's just look one, or make one up. Let's find which z corresponds to the 70th percentile. And what that means is where do we have at most 70% of our data to the left and the remaining 30% to the right? So I picked it on this side because if I picked over here, 70% is not going to be to the left. In the very middle, when z is 0, 50% is on one side, 50% is on the other. So even right here, we don't have 70 to the left. So we would have to be here, somewhere over on this side, in order to have an area of 70% or 0.7 on here. So we want this much area to the left, 70% of our data, or as a decimal, 0.7. So if we go to our table, we try to find out where do we have an area of 0.7 to the left. So we look through here, and here 0.69s, 0.7s. So the one that's closest to 0.7, this is an area, and remember these are areas. These are not the z-values. This is an area of 0.7, so I'll look in the middle of the table for 0.7. We don't have exactly 0.7, but I'm going to pick the one that's closest, so this one. So we list what z-value corresponds to this area being to the left of that number. So when z is 0.52, 0.52, that is the z-value that has this much area left of it. So that's important that we understand that concept. If we know a z then we can find out how much area is to the left of it. Because these areas are going to be associated with probability. We can use them as probabilities, or we can use them as likelihoods, as percentages, different things. So let's do a word problem. Let's do number 6. Let's try it again. All right, it says IQ scores in a certain population have a mean of 105 and a standard deviation of 11. So the mean and the standard deviation of our IQ scores. They say they're normally distributed. So we have a bell-shaped curve. If we look at our table, the mean is 0 because these are z values in the table and their corresponding areas. Remember, z stands for the number of standard deviations from the mean. So 0 means we're no standard deviations from the mean, which means we're at the mean. For a normal distribution, the mean is right in the middle. But we don't want to have a different chart for every different problem. We don't want to have a different chart for every single one. This problem has a mean of 105. If we look at a different population that has a mean of 103, we don't want to have another table. So what we do is standardize it. We take x values, which for our case, our mean, which is in the middle, is 105. And we translate those to z values. That's how we're normalizing it, or standardizing it. We are changing to how many standard deviations we are away. So let me go back to the question. So the question says, find the probability that someone has an IQ between 98 and 116. So the probability that someone's IQ is between 98 and 116. So here's the mean. 98 is below the mean, 116 is above the mean. So we want to find how likely is it that someone falls in this region between those two values. Since 100% of the data falls underneath the curve, if we can find how much of our data falls in between here, that will tell us what portion falls in there, or the probability of selecting a person that has a probability in this range. So we need to convert each of these to z's. We need to find out, let me move this number. We need to find out how far, or let's do 98, how many standard deviations is 98 from 105? So there's a formula for that. Z is our data value minus the mean over the standard deviation. So for 98 minus 105 divided by 11. So 98 minus 105, that tells us how many units we are from the mean. So 98 is 7 units below average, below the mean, but we want to know that in terms of standard deviation. So if we divide that by 11, about negative 0.64, is how many standard deviations below the mean that 98 is. 116, that's above average, so if we want to know its z-value, 116 minus the mean over 11. So 116 minus average. 116 is 11 points above average. If we divide that by 11, we get 1. So 116 is 1 standard deviation above the mean. So asking for a probability that our data value is between 116 and 98 is equivalent to saying that a particular value is between these two z-values. What's the likelihood of selecting a person whose z-value is between 1 and negative 0.64? So remember how we find that. If we look up 1, if we look up a z-value of 1, that gives us the area to the left That gives us the area to the left of 116. So we go to our table, look up a z-value of 1, and that'll be 1.00, so 0.8413. 0.8413 is the yellow region, but that includes too much. We don't want this part. If we look up negative 0.64 in the table, negative 0.64, here's negative 0.60, 1, 2, 3, 4, so negative 0.64 is 0.2611. So the area to the left here, 0.2611. So we know this entire yellow region, the area we're looking for doesn't include this portion. So we take that whole area, we subtract off the part that is counted that we don't want to include, and that gives us what's highlighted. So 0.8413 minus 0.2611, we get 0.5802. Or 58.02%. So that's how much of our data falls in this interval between an IQ of 98 and 116. So you could say, what's the likelihood that we select a person in that region? Well, that's 58%. Or if you asked what percentage of this population has an IQ between 98 and 116, well, that's 58. Those are asking the same question. All right, let's do another. Let's do this one. And the trick to these questions is understanding what you're being given and then how to use the table. So they say the weight of ripe watermelons grown on Mr. Smith's farm are normally distributed and have a standard deviation of 2.9 pounds. So we have a normal distribution. The standard deviation is 2.9 pounds. Find the mean weight of Mr. Smith's ripe watermelons if 4% weigh less than 15 pounds. So those are X values. We know that the mean is right here. We don't know what that mean is. But we know that 4% are less than 15 pounds. So we have to think about, well, where would 15 pounds occur? If we put 15 pounds over here, then less than that, that's over half. This is over half, or over 50%. So that wouldn't work. But if we put 15 pounds here, then it could be that 4% or 0.04 is to the left of that. That's possible. So we want to find out how can we have an area of 4% to the left of 15 pounds. So, in other words, for our situation, the probability of X being less than 15 pounds, we know that probability. That's 4%. That's 0.04. So we're not looking for that probability. We're looking for knowledge situation that 4% of our watermelons are in this region. What is the mean? So what can we find out? We can find out the Z value if we know the area in this left tail, the area to the left of here. We can find out the Z value that goes with this. So if we look up an area of 0.04 in the table, so 0.04, here's 0.0401, that's really, really close to 0.04. That corresponds to a Z value of negative 1.7, 1, 2, 3, 4, 5. So negative 1.75. Negative 1.75. That is the Z value that would have 4% in the left tail. So we know an X value, we know the Z value that goes with that, we know the area, and we know the standard deviation. Now remember, we have an equation that relates several of these. Z is X minus the mean over the standard deviation. Well, notice we just found Z that goes with an X of 15. We don't know the mean, but we know the standard deviation is 2.9. Notice there's one unknown there, and that's what we're looking for. We're looking for that unknown. So we need to solve our equation for X bar, the mean. So to get rid of 2.9 on bottom, multiply both sides by 2.9. So those cancel. So that leaves us 15 minus the mean on the right. On the left, 2.9 times negative 1.75, so negative 5.075. To get this by itself, we can take 15 away from both sides. So 15 minus 15 cancel. So the opposite of the mean is what we got there, minus 15. So minus 15, so that's negative 20.075. So So that's the opposite of x bar. So x bar, if we take the opposite of both sides, or you could say multiply both sides by a negative. Negative times negative is positive, negative times negative. So that gives us the mean. So even though we didn't originally know a particular z value, we just had to recognize when they gave us this 4%, that's an area that was less than a particular x. So we put an x somewhere, and then we highlighted an area of 4% to the left. So these two numbers corresponded, that 4% and that x of 15 corresponded. Well, when we have an area, we can find the z that goes with it. Once we had an x and its z, the standard deviation, that gave us enough pieces that we could have only one unknown left. So we put in what we knew and solved for what we didn't know. Some of these problems are going to give us an area, and we have to find z using the table. Some of these give us z, and we have to find the area using the table. It's just a matter of what are we given. So this is an overview of several problems from 6.2, 6.3. If you have other questions, then we can take a look at some others.